I'm Julie Liu from Footprintku AI and PalPilot. And today I'm very glad to talk about the key for truly up-to-date, accurate, and reusable EDA library. So for the past 30 years, people have been discussing that the design engineers need to have a complete, consistent, and up-to-date information for their preferred components. And it's very important for the design engineers to have access to a library system that can provide them with the most current and accurate and reusable library. However, how to build such systems remain an open question. Let's first take a look at the ecosystems for the industry today. So there are component suppliers who provide components, and the system company, OEM, ODM companies that use the components in their design and then send their designs to the manufacturers for production. Now, there are standardized data formats like Gerber file, ODB, step file, etc., that carry the design information for the manufacturing process. However, the design company is still relying on the PDF datasheets to get to know the component information. So as a result, their engineers have to manually read and process in those PDFs. And this is a very labor-intensive process, and it's also prone to mistakes. It's also redundant work because every design companies, they have to build a library for the components. So the missing piece here is whether we can have a standardized and a scalable data format for design engineers to use the components directly and easily. So if this standardized and scalable data format can fully describe the spec information from the PDF datasheet and also the entire design for manufacturing guidelines, then it will enable the quick creation of the libraries. Because the component libraries is essentially a digital data format, right? So if we have such data format can describe everything, include all the information, then it will allow us to create the libraries quickly. It also allows us to embed design for manufacturing guidelines in the library files. And in addition, it will help us to convert the library file to all the EDA formats very easy. This is also a sustainable solution because we're no longer relying on the manual work to create component libraries. So in the long run, it will save time and money. To break down this problem, so the first step is to convert the component spec information in the datasheets to a digital data. The IDT, or intelligent digitization technologies, extract all these tags, tables, graphics information such as schematic diagram, footprints, and then convert them into a machine-readable data format in order to build the library files in the next step. Then we want to use all this extracted information to construct the geometries, layers, and the pins in order to build a library file. And in this example, the automation engine placed the outlines, path stacks, pins, silk screens, etc., and make sure the constructed footprint contains all the necessary information from spec. So up till now, we have successfully constructed a footprint with exact same size and dimension from the spec datasheet, but without engineers manually reading the PDF datasheet, calculating the coordinates, and draw the footprints by hand, right? So this is the automation process, and it will save time. However, merely getting a clean library data file is not enough, because every company have their own manufacturing requirements. And therefore, their engineers have to manually modify the library files to accommodate the design for manufacturing rules. And this is also a very labor-intensive and time-costing process. A breakthrough we have is to make the design for manufacturing guidelines programmable and code them into a library creation process. And this is an illustration using a naive example to show that how the design for manufacturing conditions are analyzed in our engine and then applied directly to the library creation process to adjust the thermal pad signal pin size. But in reality, the design for manufacturing knowledge base is far more complex than the previous example. That's why we need a technique like this animation here that essentially modularizes the design for manufacturing guidelines and allow users to mix and match to create their own DFM standards. And this is essential for customizable and reusable library, because users can use different combinations of the DFM rule modules to create different versions of the libraries. And summarizing how we convert the spec PDF datasheet to a DFM-equipped library file by recognizing all the information from the spec datasheet and convert them into digital data. At the same time, we embed the design for manufacturing rules to create the final EDA library files. And last but not least, we bring these technologies on our online platforms to allow design engineers to access and customize their library files from anywhere, anytime. So the biggest impact of this transformation, I would say, is the ability to quickly and accurately create a library for the latest components. And this is truly a benefit to the design engineer, because when engineers using new components in their new design, they no longer need to pull out all the library files, make manual modification to accommodate the changes in the current spec or the current design for manufacturing requirements. So because we also modularize the design for manufacturing knowledge base, so for every new components, we only need to create the library file once, and then use different combinations of the design for manufacturing rules to create different versions of the libraries. And this is the reason why we can cater to satisfy all different requirements from different customers. No matter if it's a tier 1 customers that require a customized library with very complex design for manufacturing rules, or a mid-sized company that just need a standard DFM rules to avoid manufacturing issue, or a small company, sometimes they're seeking generic part with IPC standards. With these techniques, we can accommodate them all. So here's the takeaway. A standardized library data format that can fully describe the information in the spec datasheet and include all the design for manufacturing requirements or guidelines, then it will transform the industry. Now we can incorporate design for manufacturing rules in every library files we created, and also make them convertible to different EDA formats. But most importantly, because we embed the FM and make them modularized, we can meet the diverse requirements from the customers using different contract manufacturers and still satisfying their requirement at the same time. Okay. Yeah, I think this is a very short presentation, but I hope you get some idea of how we are using a standardized, scalable data format to transform the EDA library creation process. I'm Julie Liu. If you have any questions, please feel free to ask me, or visit our booth at 2451, which is on the second floor. We're displaying with our sister company, PalPilot, And if you are interested in learning more about these techniques or our services, you can send your inquiry to support@footprintku.com. Okay, thank you.